Friends, please submit an attendance in chat box, please. I am going to save the chat box. Pratiksha, Dhanasri, Prithviraj, you submitted an attendance.
हो सर
Okay,
केलाय सबमिट.
okay.
हाँ सर केलाय.
Okay. Thank you. I am saving the chat box and just go to share the PPT. Yes. Friends, my PPT is visible.
Yes, sir.
Okay, okay. Hello. Okay. In last lecture, अरे रे रे, कुठे गेले? Okay. In last lecture, we came to the oscillator circuit, and oscillator circuit is an frequency determining circuit, and that frequency determining circuit can determine the frequency of a oscillator circuit, which is known as a tank circuit. Tank circuit is like the work like the tank of the energy, and that energy will be converted into the energy in the form of the oscillation. Here, the tank circuit is the just a parallel circuit of the inductance and capacitor. And just in last lecture, I give the demonstration of tank circuit of these four figures. In first figure, inductance and charged capacitor are placed in parallel and switch is connected in between that. Then when switch is closed, switch become closed, that will be shown in circuit second. If switch is closed, the electrostatic energy will be starts flowing from this negative terminal to positive terminal of the capacitor. Means for the moment the capacitor acts as an electrostatic battery. It will be acts as an battery. It means just the electrostatic energy will be flowed, electrostatic current will be passed through the inductance. The flux are to be produced, and this flux will be produces a magnetic field around the inductance. As the energy, electrostatic energy of the capacitor will be discharged or it decreases, the magnetostatic energy around the coil will be increases. When the electrostatic energy will be reduces to zero, means capacitor is wholly discharged, the magnetic energy or the strength of the magnetic flux around the inductance become maximum and collapsed. And once it collapsed, that magnetic energy again starts current starts flow in that direction and charges the capacitor again. And while the charging, the negative charge will be at the topper plate, and at the down plate the positive will be positively charged. Means that upper plate of the capacitor will be negatively charged, and lower plate of the capacitor will be positively charged. That will be shown in diagram third. And here, as the magnetic flux will be reduces, the charge across the capacitor or the electrostatic energy across the capacitor will be increases, and capacitor charges in opposite polarity. In opposite polarity means hello, काय पाठवलंय बघ. ए हर्ष, राजू, फोटो पाठवलास का? हा, सांग ना मला फोन करून. Okay, friends. In third, as shown in third diagram, the polarity of the charge will be becomes inverted. It means in first the upper plate is positively charged and lower plate is negatively charged. But when once round of conversion of the energy will be takes place, that is the electrostatic energy is converted into magnetostatic energy, and again magnetostatic energy is converted into electrostatic energy. One cycle was completed. Once the cycle was completed, the charging across the capacitor will be inverted. It will become opposite. And again, when the whole magnetic energy will be collapsed, the capacitor will be charged, and again this negative charge will be starts flowing from the negative to positive in this direction, and the magnetostatic energy will be induced around the inductance. It will be again mixed opposite to direction. Means here the flux direction is upward in direction, and here the flux direction becomes downward in direction. In this way, between the capacitor and between the inductance, the interconversion of the energy will be takes place. How the interconversion of energy will be takes place? That is, the electrostatic energy across the capacitor is converted into magnetostatic energy across the inductance. Again, the magnetostatic energy across the inductance will be converted into electrostatic energy across the capacitor. It means the capacitor charges and discharges through the inductance. The magnetostatic energy or the strength of the magnetic flux will be increases, and again it collapsed and again charging the capacitor in reverse direction. In this way, in between these two component, means in capacitor and inductance, interconversion of the energy will be takes place. And if we take the output of this interconversion about these 2 points, consider this point is A point, this point is B point. Just I am taking the pen. Consider this point is A point and this point is B point. And if we take the output across the A and B point, and these 2 points, these two wires are connected to CRO. CRO means cathode ray oscilloscope, which give the visual indication of the energy. एनर्जीचं तो काय करतो, व्हिज्युअल इंडिकेशन मध्ये रूपांतर करतो. म्हणजे इलेक्ट्रिक सिग्नलचं लाईट एनर्जी मध्ये तो रूपांतर करतो, आणि आपल्याला ती लाईट एनर्जी दिसते. आणि ती जर वेव्ह बघितली तर आपल्याला कशी दिसते बघा. समजा अशी वेव्ह आपण मी ड्रॉ करणार आहे, आणि ती वेव्ह आपल्याला अशी दिसते बघा. काय दिसते बघा, त्या वेव्ह मध्ये काय झालेलं आहे, अँप्लिट्यूड कमी 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 होत जाते. पहिल्यांदा अँप्लिट्यूड जास्त आहे म्हणजे आपल्याला वेव्ह मिळते, ती उदाहरणार्थ अशी अशी वेव्ह मिळते. म्हणजे काय होतं बघा, काय होतं बघा, अँप्लिट्यूड त्याची कमी कमी होत जाते. अँप्लिट्यूड कमी होते म्हणजे काय होतं, अँप्लिट्यूड डिके होते. म्हणजे विथ रिस्पेक्ट टू टाइम, द अँप्लिट्यूड अक्रॉस द ए अँड बी, or the energy or the output across the A and B across the L and C circuit, means across the tank circuit, it will be damped, it will be reduces, it will be decreases, it will be decay with respect to time. As the t is increases, the amplitude across the tank circuit will be decreases, and such a nature will be known as a damped oscillatory nature. In last diagram or the slide, just give here I take here the help of the indicator, that will be the laser pointer, and this wave will be known as a damped wave. This wave will be known as a damped wave, where the amplitude will be decreases with respect to time. In each oscillation, amplitude across the tank circuit or the oscillatory circuit or the frequency determining circuit is going to decrease with respect to time, and such a oscillatory movement will be, such a oscillatory output will be found across the this across this tank circuit or across this oscillatory circuit, and such a output will be starts the oscillation, such a output will be starts the oscillation in DC circuit. See here, in oscillator, input is the DC, output is the AC, and in this direct current or the straight line current, just oscillation will be started. It may be damped oscillation. ऑसिलेशनचं नेचरकडे जाऊ नका. ऑसिलेशनचं नेचर इथं काय आहे? डॅम्प्ड नेचर आहे. असू दे, हरकत नाहीये. पण एका डीसी सर्किट, डीसी सिग्नल मध्ये किंवा डीसी आउटपुट मध्ये एसी म्हणजे ऑसिलेशन सुरुवात करायचं काम ह्या ऑसिलेटर डिटर्मिनिंग सर्किटने केलेलं आहे. म्हणजे कोणत्या सर्किटने केलेलं आहे? ऑसिलेटरी सर्किटने केलेलं आहे, किंवा ज्याला आपण जाऊन म्हणणार आहे दॅट इज द फ्रिक्वेन्सी डिटर्मिनिंग सर्किट असं म्हणणार आहे. या सर्किटने केलं, that will be known as an tank circuit. See here. पुढे चाललोय आपण. The once the collapsed field is recharged, आपण हे बघितलेलं आहे. Recharge capacitor and capacitor now begins to discharge the current flow in opposite direction, shows the capacitor will be fully discharged and maximum current is flowing. The sequence of, see here, the sequence of charge and discharge result in oscillating current. That is, capacitor is charging, again discharging through the inductance. Then magnetic field will be collapsed. Again it recharges the capacitor. Capacitor charges. When the electrostatic charge will be collapsed, again capacitor will be discharges through the inductance. And this sequence of interconversion of energy in between the inductance and capacitor, or the sequence of charging and discharging between the capacitor and inductance, this sequence gives the oscillatory signal, oscillatory motion about the tank circuit or about the two output A and B. The energy is alternately stored in the electric field of the capacitor and the magnetic field of the inductance. Between the capacitor and inductance, interchange of energy will be occur, and that will be known as an oscillatory circuit, or that will be known as an oscillatory moment, that will be known as an oscillatory wave, and that wave will be shown here. This is the oscillatory wave in which the amplitude will be decreases with respect to time. We know that on y-axis the current or the amplitude is to be, voltage amplitude is to be floated, and on x-axis the time is to be floated. This is the float, this is the graph of voltage amplitude versus the time, and voltage amplitude versus time. That graph, nature of the graph will be oscillatory, means the oscillation are to be produced by the tank circuit, and hence tank circuit is known as an oscillatory circuit. Please, what is the nomenclature of the tank circuit? Tank circuit here named as an oscillatory circuit because it can produces oscillation in DC signal, oscillation in the DC current. DC current मध्ये ऑसिलेशन क्रिएट करायचं काम कोण करतं मित्रांनो? हे ऑसिलेटरी सर्किट करतं. आणि पुढे जाऊन ते फ्रिक्वेन्सी डिटरमाइन करायचं पण काम कसं करतं? How it can be determine the frequency, how it can be determine the magnitude of the frequency of the oscillatory signal, that will be explained in this slide. This is the damped oscillation. We know that where the amplitude will be decreases with respect to time, then such a wave motion, such oscillatory motion will be known as a damped motion, and hence we nomenclature this wave which is observed, which was observed across the output of the tank circuit across the parallel arrangement of the inductance and capacitor, that will be known as a damped oscillation. Okay, see here. Here in practical tank circuit, there will be the resistive and radiation losses in the coil, and dielectric losses are the capacitor. We know that in tank circuit there is the inductance, and inductance is made up of the coil, and coil is straight. First it is the straight coil or the straight wire, and if it is wounded, if it is the wounded, it becomes the coil. Means each and every coil in universe has the resistive losses that will be known as an ohmic losses. Each wire of a metal has a resistance, and if the current will be passed through that wire, the resistance will be opposes the flow of the current. Means there will be the losses. Some of the energy of the some extent, some fraction of energy will be wasted to overcome the opposition of the resistance. It means that if there is the resistance is present, then there will be the wastage of energy. Some part of the energy will be wasted. At this, like that, like that, if there is the capacitor, each and every capacitor has an electrostatic losses. It will be known as a leakage. As as the storage of the water, as the storage of the water tank has the leakage, like that each and every capacitor in the world has the leakage, and the capacitive losses will be known as an electrostatic losses, and resistive losses inside the inductance will be known as an ohmic losses. It means in tank circuit there are the two component. One is the inductance and one is the capacitor. In inductance there is the resistive losses, it is known as an ohmic losses, and in capacitor there will be the leakage that will be known as an electrostatic losses. Means in tank circuit there are two types of the losses are present, two types of the opposing factors are present that will be known as an waste energy. Due to that some part of energy will be wasted. Okay, see here, during each cycle, small part of the original imported energy in terms of electrostatic energy inside the charging of the capacitor. Okay, just with connected capacitor across the battery, the capacitor will be charges that will be the imported energy in tank circuit due to the battery, and that imported energy will be wasted losses. आणि त्याचे losses कोण करतं? There are the two types of the losses. One is the ohmic losses, which is made by the inductance, and one is the electrostatic losses or the leakage, which was made by the capacitor. See here, that is the originally imported energy is used to overcome these losses, and so the amplitude of the oscillating current decreases, eventually becomes zero. What will be the concept? There are the there are the two component. One is the capacitor, other is the inductance. Capacitor will be charged, it will be charged, discharged through the inductance. Again, the magnetic energy across the inductance, it will be discharged through the capacitor. Means there will be the interconversion of the energy will be occur in between inductance and capacitor. But we know that inductance has the ohmic losses and capacitor have the electrostatic losses, that will be the leakage. Due to that losses in each conversion, in each cycle, that is the transfer of energy from inductance to transfer of energy to the capacitor, that is the one cycle. In each cycle some fraction of imported energy will be wasted. It will be wasted, it will be overcome, it will be lost to overcome the opposition made by ohmic resistance as well as the leakage or the electrostatic losses of the capacitor. Just understand in well manner why the oscillation will be damped. Why not the oscillation will be undamped or sustained output? You know that the sustained oscillation, it means its frequency and amplitude should be constant. Means that there will be constant output. But here we did not get the constant output, but we are getting the damped output. In damped, amplitude of the output will be lost with respect to time slowly. Why it is losing? Due to the interconversion energy, interconversion of energy in between the inductance and capacitor, and due to the ohmic losses inside the inductance, and due to the electrostatic losses across the capacitor. Amruta, Amruta, please unmute. Amruta, Amruta, please unmute. Amruta, please mute yourself. Okay, okay. And due to these two losses in each cycle, some part of originally imported energy will be lost, and hence we are getting, that is the we are decreasing, we are decaying the amplitude with respect to time, and we are getting the damped oscillatory motion. Therefore, the tank circuit will be produces the damped oscillation that will be shown in above diagram, and the frequency of the oscillation, what is the magnitude of the frequency of the oscillation, we are knowing the resonant frequency formula, that is f is equal to 1 upon 2 pi root of LC in denominator, that is 1 upon 2 pi root of LC. See this formula. Just I am taking the pen, I am using here the pen. See this formula, that is f is equal to 1 upon 2 pi root of LC. L is the magnitude of the inductance, C is the capacity of the capacitor, pi is the constant, that is 3.14 is the constant, and f, that is the resonant frequency of the tank circuit, will be depend upon the magnitude of the inductance and as well as the magnitude of the capacitor, that is 1 upon 2 pi root pi LC, where L is the self inductance, and that will be in terms of the Henry or the micro Henry. Henry is the unit of the inductance, and the Farad is the unit of the capacitor. And if you change the value of the inductance as well as the value of the capacitance, the value of the resonant frequency that will be occurred across the tank circuit, it will be changes. Means that one can able to change, one can hear in resonant frequency. Why it will be known as an frequency determining circuit? Because by changing the value of the inductance as well as the value of the capacitance, one can able to change the frequency of the tank circuit, or the frequency of the damped output, frequency of the damped oscillatory motion, one can able to change. Means we can get the variable frequency range just by changing the inductance or by changing the capacitance. We can able to vary the frequency of the frequency determining circuit or frequency of the tank circuit, and also the frequency of the oscillatory circuit. See what is the magical, what is the magical moment, what is the magical role of the inductance and capacitor in tank circuit. If the user can change the magnitude of the inductance, just we can, if you use the variable resistance, if we vary rheostat, if we vary the rheostat, it can changes the resistance like that. If we use the inductance, that will be known as an decayed inductance is the variable inductance. And if we vary the inductance, it can changes the in the magnitude of the inductance in terms of the Henry. Also, we can use the decayed conductance, variable conductance. And if we change the magnitude of the conductance, then the in terms of the Faraday, the magnitude of the capacitor will be changed. And due to changing these two terms, we know that in formula F is equal to 2 pi root of LC, that terms are present in denominator. And in denominator, if it will be changes, the value of F will be changes, and it will be changed the periodic time. That periodic time is the time required to complete one cycle. Consider in this wave, this is the time. Time is the periodic time, and periodic time is the time to complete one wave. One wave. This is the one wave. This is the one wave, and this is the time to complete one wave, that will be the periodic time. And periodic time of the wave is depend upon the magnitude of inductance and capacitor. By changing the magnitude of inductance and capacitor, one can able to change the periodic time. And due to F is equal to reciprocal of the periodic time. What is the F? F is equal to reciprocal of periodic time. We know that reciprocal of the periodic time is equal to frequency, and hence the frequency will be changes. And here we know that, so the frequency of the oscillation is inversely proportional to inductance and capacitor. That is, F is equal to reciprocal of T, and T is equal to, we know that, that is 1 upon 2 pi here, that is 2 pi of root of LC. F is equal to आपल्याला मिळत आहे 1 upon 2 pi root of LC. Means that here the frequency and periodic time are inversely proportional. By changing the inductance and capacitor, not only frequency but also the periodic time is to be changes. Okay, it is, it will, it will take longer period for the capacitor to charge and discharge, and this lengthen the period of the oscillation of the tank circuit. जर मी काय वापरलं मित्रांनो, इंडक्टन्स मोठा वापरला तर टी मोठा होतो, टी मोठा झाला तर एफ कमी होतो. मी इंडक्टन्स कमी वापरला तर टी कमी होतो, टी कमी झाला की एफ वाढतो, बिकॉज एफ अँड टी आर इनव्हर्सली proportional. That is the periodic time as well as the frequency of the signal are at the reciprocal proportional, at inverse proportional, and hence we are getting, the this formula, that is 1 upon 2 pi root of LC, and that the frequency will be determined by the inductance, magnitude of inductance, as well as the magnitude of the conductance or the capacitor. Okay, friends, this slide this slide gives the total understanding of the tank circuit, and how the tank circuit will be known as an oscillatory circuit, and how that oscillatory circuit will be acts to determine the frequency, and hence it will be known as an frequency determining circuit. These three roles, that is, how it is the tank circuit, how it will be worked as the oscillatory circuit, and how the oscillatory circuit work as the frequency determining circuit. In case of oscillator, it will be understand by this uh, this slide. Okay, friends, here we stop the today's lecture. Here we completed the oscillatory circuit or oscillatory tank circuit. We are, if you have any confusion, if you have any doubts, then session is open for discussion. You ask me, I will try to rectify your doubts with my best level. Okay, thank you. मित्रांनो, काही डाऊट्स आहेत?
No, sir.
श्वेता, काही डाऊट्स आहेत?
नाही.
ओके, मी शेअरिंग थांबवतो. पहिल्यांदा सगळ्यांनी अटेंडन्स द्या, प्लीज गिव्ह अटेंडन्स. आणि सगळ्यांना जरासं दिवाळीचे तेवढे 4 दिवस आपण सुट्टी देणारच आहोत, पण अलर्ट राहा, कारण जर कॉलेज सुरू झालं तर 15 जानेवारीच्या आसपास आपली पहिली एक्झाम होईल. मित्रांनो, मी काय सांगितलं, जर 1 तारखेला आपलं कॉलेज सुरू झालं 1 डिसेंबरला मित्रांनो, तर 15 जानेवारीच्या आसपास, आज आमचं पहिलं टर्म संपलेलं आहे. विद्यापीठाच्या, जरा बारकाईनं ऐकून घ्या, विद्यापीठाच्या परिपत्रकानुसार काल आमचं पहिलं टर्म संपलं. पहिलं टर्म संपलं म्हणजे पहिली सेमिस्टर होणं गरजेचं होतं, पण पॅरामेट्रिक सिच्युएशनमुळे आपण घेऊ शकलो नाही. 1 तारखेला जर फिजिकल क्लास सुरू झाला तर 15 जानेवारीला परीक्षा येण्याची शक्यता आहे मित्रांनो. त्यामुळे सगळ्यांना जरा सांगा, सगळ्यांना अलर्ट करा. मी लगेच नोट्स ट्रान्झिस्टर अँप्लिफायरच्या तुम्हाला 2 दिवसात गुगल क्लासरूमला पाठवतो, आणि आपण लगेच ट्रान्झिस्टर बायसिंगच्या, ट्रान्झिस्टर अँप्लिफायरच्या टेस्ट सुरू करूया. या 2-3 दिवसामध्ये सुरू करूया, आणि लगेचच पुन्हा आपण ऑसिलेटरकडे येऊया. ओके, पट 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 आपण टॉपिक संपत जाऊया. बोल, बोला.
तुम्ही सेमिनार पाठवला नाही गुगल क्लासरूमला?
होय होय, ऐक ना, त्या
गुगल
तिघांचे,
क्लासरूमला सेमिनारचं पाठवलं.
होय की बाळा, ऐक ना, काय झालंय, अजून मागचे जराशे आपल्याला या या पण टॉपिकचे काही माझे कन्व्हर्शन करायचे आहेत आणि ते पाठवायचे आहेत. त्याच्याबरोबर पाठवत, आता या 4 दिवसात मला वेळ आहे, मी पाठवून देतो बा श्वेता. प्रत्येकाचा सेपरेट करणार आहे मी,
हा.
आणि प्रत्येकाचा सेपरेट पाठवणार आहे. ओके, काही डाऊट्स नाही आहेत ना? प्लीज रिस्पॉन्स मी. डाऊट्स नाहीत ना? ओके, मी चॅट बॉक्स सेव्ह करतो. आता परत सगळ्यांनी स्टुडंट सेमिनार म्हणून अटेंडन्स द्या. स्टुडंट सेमिनार म्हणा. आणि मी तेजश्री कुठे गेली? तेजश्री आहे. तेजश्री,
Yes, sir.
you can share the screen and start your seminar. फर्स्ट गिव्ह अटेंडन्स. पहिल्यांदा
sir.
तू तुझा सेमिनारचा अटेंडन्स दे बाळ. आणि मी शेअरचा लॉक काढलेला आहे. तू शेअर कर आणि हवं तुझा व्हिडिओ सुद्धा ऑन कर. अगदी सगळ्यांनी व्हिडिओ ऑन केले तरी चालतात. इफ आर in position of on the video, if you are well prepared, then start your videos. कोणतरी आपला एक मित्र असते, नेहमी व्हिडिओ चालू करत असतोय. आज कुठे दिसत नाहीये. ओके तेजश्री, share your
Yes,
screen.
sir.
Share your screen and start the seminar. Friends, I am just introducing today in seminar activity our student Tejasri Mane is going to deliver her seminar on a topic of I think NAND or NOR gate. Okay, please hear that seminar in quiet, and if some ambiguities, then ask her at the end of session. That will be the answer question session or discussion session. Thank you. Towards the Tejasri. Towards the Tejasri.
Yes, sir. Good morning, all of you. Today we are study about the NAND gate. In this point, I am going to discuss